Use row operations on the augmented matrix as far as necessary to determine whether the system is independent, dependent, or inconsistent. So to answer this question, we're going to go ahead and use augmented matrices, which means we're going to work with only the numbers, and the variables we could put them at the very end. So just take the numbers. We would say take the coefficients. That's the number part. And rewrite the system like this. Notice these braces here. And these are the numbers in front of the x, y, and z. Here is where the equal sign used to be. And this is the other side of the equal sign, the constants. Now that you have it in this form, you don't have to be writing the variables over and over. That's the advantage. You save some time. Now our objective when we're solving a system, whether with the variables as a system or in augmented matrix form with a matrix, is to get zeros right here. So now we're going to use row operations, which means you're going to multiply a row by a number and add it to another row and replace a row. Those are row operations. So we get a 0 here, here, and here. At the very end, the look is going to tell us what we have. We don't need to know ahead of time. So what I'm going to do is I'm going to multiply row 3 by a 2, and then slide it over. And then row 2, I'm going to slide it over. Then I'm going to combine like terms. And notice we get a 0 where we need it in the position 1. So 0, 0, 0, negative 64. This is going to replace row 2. The other two stay there. So make your replacement. And this is what the augmented matrix looks like now. This is the one that was replaced. Now I'm going to go for a 0 here. So I could slide row 1 over, slide row 3 over, and these guys are ready to be combined to get our 0 where we need it. We didn't have to multiply any of them by a number, any of the rows. So you go like terms, combine like terms, and this result is going to replace row 3. So this is going to be removed, and this one's coming in. And here it is. Now this is beginning to look like we have more zeros than we were looking for. We just needed these 3 zeros here. So now that you have all these zeros, you notice that if you were to multiply row 3 by a negative 2, you would get this result. And if you were at these 2 rows, you would get this result. So we wanted to replace row 3, but you could have replaced row 2. You could replace any of the rows that were used. So if you use row 2 and 3, you could replace any of those. But we wanted to replace row 3 to get our 3 zeros here. So replace row 3. And this is what it looks like. Now, when you get this look, when you get a row of zeros, this is the conclusion. A row of zeros means the system is dependent. What does it mean for a system to be dependent? That means that we really had 2 different equations, not 3 different ones. These 2 were just multiples of each other. In other words, these 2 were the same equation. That's what it means in terms of equations. It's a dependent system. And when you have a dependent system, that implies an infinite number of solutions. But all they wanted to know this time was, is it dependent, independent, or inconsistent? So this is a dependent system when you get a row of zeros. Now, to be inconsistent, if it would have been inconsistent, this is what would have happened at the end. An example of a system that has no solution. Zeros up to the vertical bar and non-zero number on the other side of the vertical bar. If you would have gotten zeros up to the vertical bar and a non-zero constant on the other side, then you would have said no solution. And this would have been an example of an inconsistent system, one that doesn't have a solution.